Hi all. Today we can discuss about the next portion of our signal encoding techniques. We had already discussed about NRZ mechanism and its variations. Now you can study the next encoding techniques, that is multi-level binary. So this multi-level binary, which addresses some of the deficiencies of NRZ codes, it uses more than two signal levels, and there are two types of multi-level binaries are there. One is bipolar AMI mechanism, and another one is a pseudo-ternary. Okay, so already we had discussed about signal encoding techniques. What are the types of signal encoding techniques? In which first one is NRZ mechanism, and it has two variations, that is NRZ-L and NRZ-I. Now we can move on to next encoding techniques, that is multi-level binary. There are two types of multi-level binary mechanism. One is bipolar AMI and another one is pseudo-ternary. Okay, so first mechanism is bipolar AMI. What is the significance of this bipolar AMI signal encoding technique? In which binary 0 is represented by absence of voltage or the no line signal. Okay, actually what is signal encoding? We are encoding the data or information into a signal form, or converting the data into a signal form. We have some binary data, that is binary 0 and binary 1, etc. So we can convert it into a signal that will be transmitted over a transmission medium. That mechanism is actually known as signal encoding. Okay, there are multiple types of signal encoding techniques, in which first one you have studied is NRZ and its variations. Now we can study about multi-level binary. There are of two types. One is bipolar AMI and another one is pseudo-ternary. So നിങ്ങൾ പഠിച്ചത് സിഗ്നൽ എൻകോഡിംഗ് ടെക്നിക്സിൻ്റെ ഇൻട്രൊഡക്ഷനും അതിൻ്റെ ഫസ്റ്റ് ടെക്നിക് NRZ മെക്കാനിസം ആയിരുന്നു പഠിച്ചത്. അതിൽ നിങ്ങൾക്ക് മനസ്സിലായിട്ടുണ്ടാവും ബൈനറി ഡാറ്റയെ എങ്ങനെയാണ് നിങ്ങൾ റെപ്രസെൻറ്റ് ചെയ്യുന്നത്, സിഗ്നലായിട്ട് എങ്ങനെ റെപ്രസെൻറ്റ് ചെയ്യുന്നു, NRZ എങ്ങനെയാണ്, NRZ-L എങ്ങനെയാണ്, NRZ-I എങ്ങനെയാണ് എന്നുള്ളതാണ് കഴിഞ്ഞ വീഡിയോയിൽ നമ്മൾ നോക്കിയത്. ഇപ്പം നമ്മൾ നോക്കാൻ പോകുന്നത് നെക്സ്റ്റ് എൻകോഡിംഗ് ടെക്നിക്കായ മൾട്ടി ലെവൽ ബൈനറി. അതിന് രണ്ട് വേരിയേഷൻസ് അല്ലെങ്കിൽ രണ്ട് ടൈപ്സ് ഉണ്ട്. ഒന്ന് ബൈപോളാർ AMI, രണ്ടാമത്തത് pseudo-ternary. ഓക്കെ, so first we can study bipolar AMI, in which binary 0 is represented by absence of voltage or no line signal, and the binary 1 is represented by a positive voltage or a negative voltage. So there must be an alternate polarity for the binary 1, right? Maybe the binary 1 is represented by a positive voltage, or it may be represented by a negative voltage. So it has different polarity. Okay, so what are the advantages of this bipolar AMI? Here there is a synchronization is there if a long string of 1 occurs, because there is no loss of synchronization. Also each one introduces a transition and there is a resynchronization at the receiver. So the resynchronization mechanism is also handled in receiver. That is the main advantage of this bipolar AMI over NRZ. Okay, so the binary 0 is represented by absence of voltage and binary 1 is represented by positive or negative voltage. And the main advantage is the synchronization and resynchronization property in the system. Okay. Also here the binary 1 signals have an alternating voltage from positive to negative. So there is no net DC component is there. That is also another advantage. No net DC components exist in the system. Although the bandwidth is less than that of the NRZ, that is also an advantage. Here the pulse alternation property is there. It provides a better error detection mechanism in the case of multi-level binary. compared to NRZ. So actually we have multiple advantages of this bipolar AMI over NRZ. First one is synchronization, and we have a better error detection. Also the bandwidth is less, and we have no net DC components in bipolar AMI. So main four advantages of bipolar AMI over NRZ. Okay, so how to represent the data in a signal form in bipolar AMI? So first one is a clocking mechanism. Okay, we have a data 10100111001. That is the digital data that is used for encoding in a bipolar AMI. So how to represent in bipolar AMI? Binary 0 is represented by absence of voltage. You can see the second bit is binary 0. It is represented by an absence of voltage or a no line signal, right? And the binary 1 can be represented by a positive voltage or it may be negative voltage. So the first bit, it's a binary 1. It is represented by a positive voltage. You can see in this figure, right? And the next, third bit is also a binary 1. How it is represented? It is represented as a negative voltage. Okay, so binary 1 has an alternate polarity or different polarities at different situations. Okay, first binary 1 have a positive voltage, and the third binary 1 has, second binary 1 has a negative voltage, but 0 is represented as a absence of voltage. Okay, it is represented as along the x direction, right? So no line signal. Okay, so this is the significance of bipolar AMI. Is it clear? Next, we have a second category of multi-level binaries, pseudo-ternary. Here the binary 1 is represented by absence of voltage. Okay, in bipolar AMI, how it is represented? Binary 1 is represented as positive or negative voltage. Okay, here binary 1 is represented as absence of voltage. Actually, it is the inverse of bipolar AMI, right? Here the binary 0 is represented by an alternating positive and negative pulses. Also, there is a degree of synchronization is there, or resynchronization at the receiver is there. It overcomes some of the problems of the NR set. Okay. So, this is the representation. You can this is the representation you can see in the figure. That is, we have a digital data 010010. So in AMI, how it is represented? 0 is represented as an absence of voltage, right? But in pseudo ternary, you can see it's a positive voltage. Am I correct? Okay. Next bit is 1. How it is represented in AMI? It is a positive voltage, right? And in pseudo ternary, it is absence of voltage. Okay. Next is a 0. 0 is represented in AMI as no line signal. Again, it's a 0. It's a no line signal. But in the pseudo ternary, you can see one is negative voltage, one is positive voltage. Depends upon the user. It can represented by negative or it's a voltage. Or depends upon the system. You can represent it binary 0 as a positive voltage or a negative voltage. Okay. From this figure, you can compare this AMI and pseudo ternary mechanism. Okay, so the second encoding mechanism is multi-level binary, in which two of them are there. One is bipolar AMI and another one is pseudo-ternary. And the next category of signal encoding mechanism is biphase. So it overcomes the limitations of NRZ as well as some multi-level binary mechanism. There are two types. One is Manchester encoding and another one is differential Manchester encoding. So here in both Manchester and differential Manchester, actually the transition at the middle of each bit is there. So in Manchester encoding, a low to high transition represents 1. Okay, a low to high transition which represents 1 and high to low transition which represents a 0. There is no absence of voltage, or a complete positive or negative voltage is not there. Here the transition at middle of the bit. That is the main point in biphase technique. Okay. Transition at the middle of each bit period. Okay. And low to high it's 1, and high to low it is 0 in Manchester encoding. But in the case of differential Manchester encoding, the mid-bit transition is only used for some clocking mechanism. Here in differential Manchester, the encoding of 0 is represented by a presence of transition at the beginning of bit period. 1 is represented by the absence of transition at the beginning of bit period. Here some of the advantages are synchronization, now DC component, error detection, wider bandwidth, etc. when compared to this multi-level binary and NRZ. So the comparison is from NRZ to biphase. Its bandwidth is increasing, less wider bandwidth in biphase mechanism than that of multi-level. Error detection is one of the advantage. No net DC component is another advantage. Also synchronization. So you can see in this figure how to represent a particular digital data in Manchester and differential Manchester. So in in a Manchester, if 0 is there, then it's a high to low transition. Okay, you can see in the first figure there is a transition from high to low, right? 0 is represented. Okay, but at the transition at the middle of the bit. Okay, transition at the middle of each bit. From high to low it is represented as 0. For bit 1 it is from low to high. Next third bit is 0, so from high to low. Then again 0. How it is represented? Along the y-axis it moves up. Then from high to low there is a transition. You can see in figure we have a digital data 0, 1, 0, 0, 1, 1. Okay. 0 from high to low. Then from low to high it is 1. Then from high to low it is 0. Again we have a 0 at fourth bit. Right. So we have a transition from high to low. Right. So we are moving along the y-axis. Then from high to low we can represent that 0. That is Manchester. Okay. In the case of differential Manchester, low to high transition for 0, then high to low transition for 1. Again, we have a 0. If it is 1, there is no transition. Okay, but if it is 0, there is inversion is there. Right. So in the next case, we have also a 0, so there will be an inversion. But next is a 1, there is no transition. So along the x-axis it moves. Then from low to high, it represented as 1. Then again 1, there is no transition. At the middle of the bit, it is transition is happen. So in the case of differential Manchester, you can see no inversion is there. Inversion is there. If it is a 1, no inversion. If it is a 0, it's an inversion mechanism. Clear? So these are all about Manchester mechanism and differential Manchester mechanism. And you have a task in this video. You can compare this NRZ, NRZ, NRZI, bipolar AMI and pseudo-ternary Manchester and differential Manchester by using this slide. You can check it. Next, how to represent the biphase modulation rate. Actually, data rate is bits per second and the modulation rate is signal elements per second. That is, data rate is used for the digital data and modulation rate is used for the signals. Okay, so the data rate can be represented as 1 by TB and modulation rate of Manchester can be represented by 2 by TB. What is actually TB? TB is the bit duration. Okay, and how this modulation rate is expressed? D is equal to R by log 2 M. R is the data rate and M is the number of different signal elements, and M can be represented as 2 raised to L. L is the number of bits per signal element. So how the modulation rate of a Manchester mechanism can be expressed? So actually by using the bit duration, it can be represented as 2 by TB. By using the data rate, we can be represented as R by log 2 M. So actually we had studied the digital data to digital encoding mechanism. Now we can study the digital data to analog signal conversion, how it is happen, how the digital data is converted converted into analog signal conversion. So by using the three basic encoding mechanism, we can convert this digital data to analog signal. We have amplitude shift keying, frequency shift keying, and phase shift key. Okay. So first one, we have amplitude shift key. So നമ്മൾ ഇത്രയും നേരം നോക്കിയത് ഡിജിറ്റൽ ഡാറ്റയെ എങ്ങനെ ഡിജിറ്റൽ സിഗ്നൽ ആക്കി കൺവേർട്ട് ചെയ്യുന്നു. അതിലുള്ള മെക്കാനിസം നിങ്ങൾ നോക്കിയത് NRZ and its variation, multi-level binary and its variation, biphase and its variations. Okay. So NRZ മൂന്ന് ആൾക്കാർ, NRZ default NRZ, NRZL, NRZI, multi-level binary, bipolar AMI and pseudo-ternary, biphase, differential Manchester and Manchester. So 7 mechanisms that's used for the digital data to digital signal conversion. Now we can study the digital data to analog conversion by using the 3 mechanisms. Which are they? One is amplitude shift keying, next is frequency shift keying, then phase shift key. So first one is amplitude shift keying. How it is represented? Here also 2 binary values can be represented by using 2 different carrier frequency, 2 different amplitude of carrier frequency. Here the one of the amplitude is 0 and one of the amplitude is represented by a constant amplitude, right? So in amplitude shift key, we are using 2 different amplitudes to represent the binary 0 and 1. Okay, amplitude shift keying il രണ്ട് ആംപ്ലിറ്റ്യൂഡ് യൂസ് ചെയ്യുന്നു, രണ്ട് ബൈനറിയെ റെപ്രസെന്റ് ചെയ്യാൻ. ബൈനറി 1ന് വേണ്ടിയിട്ട് ഒരു പെർട്ടിക്കുലർ ആംപ്ലിറ്റ്യൂഡ് ആയിരിക്കും, ബൈനറി 0ന് വേണ്ടിയിട്ട് ഒരു പെർട്ടിക്കുലർ ആംപ്ലിറ്റ്യൂഡ് ആയിരിക്കും. One amplitude is 0, other amplitude is a constant value. Okay, so the signal is represented as, for binary 1 we are using a amplitude, but for binary 0 it's used as 0 amplitude, right? A cos 2 pi fct, which is used for representing binary 1, and for binary 0 we are using an amplitude as 0. Okay, so mainly this amplitude shift keying is used in optical fiber, LED transmitters and laser transmitter, etc. So how it is represented? Actually this is the representation of ASK modulated output wave. We have a 0 voltage and a 1 voltage, that is the binary data. So for 0 voltage we are using a 0 amplitude, and for 1 voltage we are using some frequencies there, you can see. And next you can see a 0, so it's an absence of amplitude, and we have a 1, so it's represented by a small carrier frequency amplitude. Next we have again 0, it's represented by absence of voltage. Next we have a long 1 representation. Then we have a large amplitude representation in ASK modulated output wave. So this is the representation of amplitude shift keying. It is the first mechanism for digital data to analog signal conversion. Thank you.